Here is a Kenmore air conditioner. This is a 5600 BTU model from 2002. It's model number 253-720-55200. It has 13 ounces of R22. Made by the Electrolux. And it has that stupid design with those studs screwed to the back of the bulkhead that are a joke to remove. I absolutely abhor this design when it comes to servicing. Unfortunately, these are worth keeping around because it's an excellent design in terms of performance and efficiency. This was originally my grandfather's machine, and we'll get into the reason why it's over here in just a moment. I have all the original documentation. He bought it in April 20 of 2002. So you can see made in January, purchased only 3 months later in April. And unfortunately, I don't seem to have the original receipt here, but we have all this energy guide nonsense. We have the manual. What's interesting about this is that this is 11, and these really have not become much more efficient at all over the last 20-something years. The newer ones might be 12 on a top-of-the-line model. As far as this conventional design goes, of course the inverter ones you can get higher efficiency, but these basic ones have really not become any more efficient in the last couple of decades. This is the original box. Energy efficient. Yep, that it was. And we have the remote here. And these were in the box, so I'll keep the bag, but those can just go right in the trash as far as I'm concerned. And it looks like one of these has come out of there, so we'll have to fix that. But other than that, this is in quite good condition. So my grandfather was the original owner of this machine, and he drilled the drain hole. So the majority of the machine is pretty much rust free. I'm gonna get I want to get the machine plugged in first in case it's got some stupid 3-minute delay nonsense. The 3-minute delay is not nonsense, but the initial plug-in delay is nonsense. Alright, it's plugged up now. I'm going to get out the drop light so we can take a look inside. I have cleaned this before, but it's been a couple years because he recently started to insist that he puts the air conditioners in by himself. So he's been cleaning them. Yeah, it's not bad in there. The fan motor is a Welling fan motor, 0.5 amps. That's a pretty well-known brand. Doesn't necessarily make it that great. Well, I think those are generally okay. Yeah, very little rust in there. Let's take a look at the condenser. Yeah, it's in good shape all the way down to the bottom. Very little rust in there at all. Let's see if we can take a quick look at the compressor. Find out what the brand of it is. It's an LG. Which, although I generally don't like that brand, apparently years ago it was actually decent. Alright, so let's put this back on the tripod here and we'll get this started up. Whoa. That's on fan only. It's about 73 degrees in the room today, so we don't have much of a load to test it under. On fan, we'll go down to low. It is 0.46 amps, 56 watts with a power factor of 0.98. On medium, it is 0.449 amps, 57 watts with a power factor of 0.98. And on high, it is 0.53 amps, 61 watts with a power factor of 0.95. So I have to check the cap. I would have expected a little higher power factor than that. The coil looks kind of chewed up on the inside. That's a little weird. That's really quite odd. The heck is it like that for? That is really odd. Oh, it's got excellent airflow though. Top to bottom, it's clear. Get out the temperature here, and then we'll switch it over to cool, and then we'll talk about, as the head pressure builds, why it's over here. Okay. 3.24 amps. You can hear it building pressure already. So the compressor started up pretty gracefully. It's getting much louder as the pressure builds, but I suppose that makes good sense. Yeah, the coil's pretty dusty, so we should clean that out. Looks like it's a 2-layer thick evaporator. Alright, so the reason why this is over here is because I've been told for the last several years that it does not work. More specifically, that it does not take the humidity out of the air. So of course I went over there and I turned it on and let it run for a while, and condensation was pouring out the unit and it was cooling and everything was fine. So the reason why this is allegedly not working is it's a user error scenario. At my grandparents' house, in the kitchen and dining room area, is the Carrier International, which is a 1-ton. And then in my grandmother's room there is a 6,000 BTU piece of junk GE unit, which by some miracle still works. That is a 6,000, so it's a half-ton in a 150 square foot room maybe. And then in my grandfather's room there was this one, which is maybe a 100 square foot room. It's not big, and they might turn on the air conditioners when it gets to like 80 or 82, and they only set them to like 78, 76. So the house is well insulated. There's no large windows facing the south side, and so what happens is the machines run for 10 or 15 minutes and then they satisfy. So, this is a fairly common problem, is when you oversize equipment like this, it does not take the moisture out, because the coil will get cold and the water will condense on the coil, and then when the compressor is shut off, the coil returns to ambient temperature, pretty quickly. I'd say within a minute or two. And once the coil is no longer cold, all that moisture that's on there, it just blows back into the room. And since we perceive humidity relatively to the temperature, the relative humidity goes up as a result of operating the machine for 10 minutes, lowering the temperature, and then putting all the moisture back in the room. So I've said a million times, turn on one unit, put the temperature all the way down, and let the one unit handle the whole house. But my grandmother wants to keep the bedroom door shut because she have air filter on, and my grandfather wants to hear the compressor turn on and off like it's theoretically supposed to, because he's an engineer and he likes things to work in theory. And so it just, the stuff never gets used properly, or the way that it needs to be used to achieve the required result. I think my grandmother's bedroom is the worst. I've seen the humidity in there up to 86% one time. It was just ridiculous. And so of course the machine always gets full of mold, and that's another problem. So, and now this year or the last couple of years, my grandfather has been insisting upon installing the machines by himself. So this year I decided to take this one and swap it for a newer one that's much more lightweight and only 5,000 BTU, in hopes that maybe it'll dehumidify a little better because the capacity is a little bit lower. I ended up giving him that West Point one, which I cleaned out, was working fine. I had ran that one in the garage for weeks on end, and it was working pretty good. So he's got that one now. It's lightweight enough for him to move around fairly easily. And now I have this one. And as I recall it doing, it's running perfectly fine. It's 74 going in, 53 going out. That's, what we should get. We should get about a 20-degree split. A lot of these 22 machines that are very powerful will give you much more than 20, but a 20 delta is 100% satisfactory. So as far as I'm concerned, the machine is working properly. Good airflow out the back. It's pretty warm. 3.84 amps, 412 the watts, power factor 0.91. And one of the things I like about these is that they're very quiet. Very, very quiet indoor fan. And a lot of collectors say, oh, this is so new, it's junk. Ugh. I think this is still a very well made piece of equipment. And next month, in July, when the light bill rate goes up 30%, which will now turn a $300 bill into an almost $400 bill, I would absolutely be content running something like this that just pulls 3.5 amps, 4 amps, as opposed to something that pulls 6 or 7. Only because it works the same. This is kind of some of the last, the very, very early 2000s R22 stuff was the last of the really decent equipment. Once you get past this, they're just not worth much. But this works fine. It's blowing cold. Let's see what the coil's doing in here. Make sure we don't have any ice or anything crazy going on. We have a little bit of ice at the bottom, which is not really correct, but this is the first run, so we got to give it some time. Let it build up the head pressure and so forth. Cold about halfway up. hear the compressor just went under a lot less load with the fan on high. Ice just melted off that rung. Alright, well, I'm going to let this run for a while, and then we'll come back on the video in about maybe 15 minutes, and we'll see where it's at. It's been about 15 minutes, and the machine is cooling down to 47 degrees, with 75 going in, so that's quite satisfactory performance. Power draw is 4.05 amps. It's allowed to take 4.9, so that's pretty reasonable. The only thing that's kind of odd here, it feels perfectly cold all the way across. It feels as cold as it should. But what's kind of weird is that there is a little bit of ice in here. Now granted, the fan is on low, but it needs to be able to operate on low at 75 degrees. There's some ice up to about halfway to the top. Now, this rung is cold. This rung is cold. And this rung is just kind of cool. None of it's ambient temperature, but it's not as cold as it should be. And I checked the return line and it's not sweating. Now, that's not really correct, but if you look at the stupid mismatched metals panel there, right where the frost stops, the rust also stops. So it would appear that only the lower portion of the coil is doing most of the work, and it's been doing that for an extended period of time, a very long period of time. So I don't know what's up with that. It's certainly coming out cold enough. The power draw is almost 4.1 now, which out of 4.9 it's super reasonable. I mean, some might want to say it's low on gas, but I think this just might be the way it operates. If it wasn't so rusted like that, I would feel differently, but it's clearly been like this for a very, very long period of time. I don't think it would be making all that much noise if it was out of gas. So, I don't know. Maybe that's just the way these work. I'm not sure. Although I've been around this thing much of my life, I've never really observed it from a technical perspective other than feeling the output temperature of the air, which has always been satisfactory. So, I don't know. To me, it's fine. Like I said, in the summertime, it pulls plenty of moisture and it drips and drips as long as it's running. But I don't know, if you put it in a tiny room and shut the door, it's not going to work right. So anyways, that's that. I might throw this in the computer room for a little while. I do want to use it somewhere at some point because it's a nice quiet machine. Maybe I'll put it in somewhere in July once the light bill goes up.